Okay, these are notes for Wednesday, October the 20th. We're going to find out function rules by taking tables, figuring out what the equation for the table is, and then figuring out the missing term. So basically the first three steps of this process, you're going to they're kind of memory steps, really. You're going to do this process the same every single time on every single problem, and then the other steps are a little more computational. So the very first thing you do to find the function rule for a list of numbers is to take the numbers right here, the ones that are the position and sequence. That just means 1 means it's the first number, 2 means it's the second number, 3 means it's the third number. So like, for example, the 12 is first, the 8 is second, the 4 is third. You're going to rewrite those numbers here in the center, and you're going to put them in parentheses. So again, that's a memory step. First step is to write the numbers down. The second step is to put them all in parentheses. You will do that process each time you fill in a table. So that's the first and second step. There's only 5, so this is a pretty short process. The third step is to take the problems that are in your pattern and write them in the value of term problem. So the first number is a 12, and the second one is an 8. And then you've got 4, and then you've got 0. So the first 3 steps, the first step is to write the position in sequence numbers. Basically, you're transferring them to the process column, and then you put all those numbers in parentheses. The third step is to take all of the numbers in the problem, which would be these up here, and write them in the value of term. Okay, now let's start working on our function rule. The first thing we need to find, this is step number 4, is called the rate of change. And basically what you do is look at your pattern and figure out how much it's changing from one term to the next. For example, from 12 to 8, it went down 4. From 8 to 4, it went down 4. From 4 to 0, it went down 4. So that's our rate of change number is 4. You're going to take that rate of change number and you're going to write it in the very front of your process column. And of course you do that every single time. So all the rates of change for these this problem here is going to be -4. Now your process column is like your math column. Basically, whatever your process is, that should equal the value of the term. So if I'm looking at this to check it to see if it's right, in the first one I've got -4 times 1. Technically that should equal 12. And we notice that it doesn't. Look at the next one. -4 times 2 is -8, and that should be equaling 8, and it's not. Likewise, -4 times 3 is -12, and that should equal 4. So we've got a problem here, and this is where your last and final step comes in, which is called the fixed number. I like to call it the fix-it number because basically we need this process column to add up correctly, and it isn't. So I'm trying to think of a number that I could add or subtract to my process column that would make it come out true. -4 times 1 is -4. What could I add to that to make it equal 12? And after a little figuring and maybe playing around on my calculator, I discovered that it's 16. -4 times 1 is -4 plus 16 would equal 12. So that's going to be my fixed number or my fix-it number. But I don't want to just do the first one. I want to check several to make sure that I've actually got it right. Occasionally you can make a small mistake on your rate of change, and then obviously your fix-it number wouldn't work. -4 times 2 is -8. If I add 16 to -8, I get +8. -4 times 3 is -12 plus 16 is 4. So I see they're checking out, so I'm going to go ahead and fill in all the way down. And now I've got my function rule. This last box here tells you what your equation is. If I take -4 and I multiply it times n, remember n is the position in the sequence, like is it the first number, is it the 9th number, whatever, and then I add 16 to it, that will give me the term that I'm in search of. So if I'm looking for the 14th term, I'm going to take -4, multiply it times 14, and then add 16 to it. If I do that, I get -40. That would be the 14th term, -40. So basically you just do this process for each problem. Sometimes they're harder depending on the numbers. Occasionally it gets a little bit more challenging with fractions, but most of the time it's this basic process. So I'm going to work on example 2, putting each one of my numbers down, and of course putting them in parentheses. That's the first and second steps. My third step is to take the problem we're actually dealing with, the pattern, and write it in the value of term. Fourth and really most important step, let's find the rate of change. How much is it changing from here to here, or there to there, or there to there? And I notice each time that it's going down 3. So that's my rate of change number, and I'm going to write that number out in front of my process column. And then finally I need to see, okay, is this correct? Do I need to fix it? Well, negative 3 times 1 is negative 3, but I need it to equal positive 4, and that obviously doesn't. So again, with some playing around the calculator or just thinking, I'm going to figure out, hey, I need to add 7. Negative 3 plus 7 is 4. Negative 6 plus 7 is 1. Negative 9 plus 7 is negative 2, and so I realize that plus 7 is my fixed number all the way down, which gives me my function rule. Negative 3 times n plus 7. So I need to find the 51st term. If I take negative 3 and I multiply it times 51 and then add 7, I'm going to get negative 146. And that would be my 51st term. That would be its value is negative 146. All right, let's look at a few more examples here. Let's see, let me see if I can switch to the next. Oh, there we go. All right, for the next one, I've got my same process again. I'm going to put all my little guys here in the center in parentheses. I'm going to take my actual terms and fill them in over here. And now let's find the rate of change. From 9 to 13, it's going up 4. It's also going up 4 there and there. So the rate of change should be consistent every time. If you get to a problem and you're not finding a consistent rate of change, then you need to go back and double check the problem, make sure you've written it down correctly, because it should, with the problems we're doing now, they should all be pretty consistent. So my 4 goes out in front. All right, let's fix this thing. 4 times 1 is 4. What will I add or subtract to make it equal 9? In this case, it would be 5. And likewise, all the way down, I'm going to have plus 5 as my fix-it number. So my function rule I've created right here, 4 times n, oops, I forgot to put him in parentheses, plus 5. If I'm trying to find the 1,000th term, that seems really hard and that's really huge. But basically, you just multiply 4 times 1,000 plus 5, and of course that would equal 4,005. All right, last one. Now I've got fractions, and I know everybody grumbles, oh, fractions, these are going to be so hard. This is one of those rare cases, because I really like fractions and I think it's important. To me, it's more accurate to leave your answers in fractions, especially when you start working with repeating decimals and things like that. I would suggest on this type of problem to go ahead and put your fractions as decimals. So I'm going to fill in my process column first with all my position and sequence numbers. And instead of writing my fractions in the value of term, I'm going to change them to decimals. So instead of writing 1/2, let's put it as 0.5. And instead of writing 3/4, let's put it as 0.75. I think for this problem it'll be a little easier to do if you have it in decimal form. 1 obviously is not going to change. That's still going to be 1. And then 5/4, if I divide that out, that's going to give me 1.25. So looking at my rate of change, it is harder because they're decimals, but I think I can see from here to here, it's going up 1/4. It's going up 0.25. Likewise from there to there, it goes up 0.25, and even on the last one. So I see that's my rate of change. I've got 0.25 on every single one. So once I get all these written in, I now need to decide, okay, I know it's probably not going to equal. I need to see if I need to come up with a fix-it number. It is possible that your process column will be perfect and there's not a need to add or subtract any number, but usually you have another number to put on. So 0.25 times 1 is 0.25. I need it to equal 0.50. So what would I have to add to it? Well, that would be 0.25. Likewise, 0.25 times 2 is 0.50, and if I add another 0.25 onto it, that equals the 0.75 I need. So I see my fix-it number this time, or my fixed number, is 0.25. So when I get down to the very bottom step, right here, there's my little function rule, 0.25 times n plus 0.25, and if I'm looking for the 20th term, 0.25 times 20 plus 0.25 will equal 5.25. And this process again is called the table method. You use this table method to come up with a function rule to be able to find a missing term in a pattern.